Hey everyone, this is the second video in the series that is going to be talking about the different kinds of carbocation rearrangements. So in the first video in this series, we talked about the carbocation rearrangements of SN1 reactions in the hydride shift, right? And in this video, we're going to be talking about the next one, which is the methyl shift. Okay. So methyl shifts and hydride shifts, very similar, almost the exact same thing. The only difference is in hydride shifts, we move a hydrogen, and in methyl shifts, we move a, you guessed it, methyl group. So we're going to do two examples here really quickly, and then we'll call it a day. All right. So this very first one I'm going to be doing with bromine, and we're going to put it through water. And then what's my product? Well, my product is, remember, wedge and a dash, this along with the enantiomer of it, right? This. So these are my two major products that I have to explain, all right? So go ahead and draw the mechanism for this now. So as we've talked about a million times already, the very first step of a SN1 reaction is the leaving of the leaving group, right? So bromine is just going to say, I'll see you later. So it's going to up and leave. So bromine left. And then what does that get me? Well, that gets me my carbocation intermediate, and that's where my shifting can begin to occur. So that's where my carbocation is. So now you'll see that on this adjacent carbon, I have two methyl groups, right? So I can move a methyl group. Now, let me say that if a hydride shift or a methyl shift could occur, right, the molecule is going to prefer to shift a hydrogen instead of a methyl. Why? Because a hydrogen is easier to move than a methyl. A hydrogen is smaller, right? So it's going to be easier for the molecule to move that hydrogen versus a methyl. But here I have two methyl groups here. So notice that if I move this methyl here, right, so I'm going to move that methyl there, and then I'm going to write over the arrow that this is a methyl shift. Okay. If I move that methyl there, then what do I get? Well, you'll notice that I started with a 2-degree carbocation. I move this methyl here, and then there's one methyl here. This carbon right here just lost a bond, so now I have a positive charge here. Now I have a 3-degree, a tertiary carbocation. So this is a more stable carbocation. So that's why this rearrangement occurred. Okay. So that's all that's going on with my methyl shift. All right. And now that I've done my shift, the reaction just proceeds as normal. Okay. So we're going to have H2O come in, and it's going to act as a nucleophile on the positively charged carbocation. And then we get our OH2 that is positively charged. And then another water is going to come in. Since this is our solvent, we can have another one come in and go there and take that hydrogen off. And then I'm done. So I get that. And then my products I just drew earlier, right? I get one on a wedge and I get another one on a dash. And then let's not forget, we also get H3O plus. H3O plus, all right? So this is my methyl shift, right? Not anything too crazy, I don't think. If you can do a hydride shift, you can do a methyl shift, right? So I don't think that there's anything too terrible about the methyl shift. So now what I want to do is do one more example of the methyl shift. You'll remember that in the video on the hydride shift, whenever I talked about that, the second example I did was with a primary alkyl halide. In this one, I'm going to do a primary alkyl halide with the methyl, okay? Just to kind of show you what's going on, because I know the primary one is a little strange where the shift happens at the same time that the leaving group leaves, right? So just to kind of clear the air with that, let's go ahead and take a look at this. Okay. So the example that I'm going to use here is very similar to the one that we just did. The only difference being it's going to be a couple less carbons. All right. So I'm going to be starting with this, excuse me, sorry. And I'm going to have water. And then what is my major product going to be? Well, my major product, sorry, is going to be this and this, okay? These are my both my major products, okay? And we're going to write the mechanism that's going to explain each of these, okay? So here we go. So remember, very first step in a SN1 reaction is the carbon-chlorine bond breaks, right? But not so fast, because remember, if this carbon-chlorine bond breaks, what am I going to form? I form a primary carbocation, right? Do I want to form a primary carbocation? No, they are very unstable. So what am I going to do instead? Well, I'm going to have the shift occur. So this methyl shift is going to occur. So the methyl is going to shift. And then the leaving group leaves at the very same time, okay? So now, what do I get? Well, leaving group left, right? So now I have an extra methyl here, and leaving group left, right? So I'm going to draw my chlorine with a negative charge here. And then, sorry about that. And then I just have one methyl here, right? So this lost a bond. So now this has a +1 charge right here, okay? So now it's just going to continue as normal, right? Nothing too crazy. My water is going to come in and attack the carbocation. And then what do I get here? Well, the same thing I always get, right? I get this, and then water is going to come in again. It's going to take a hydrogen off, and then those electrons are going to go on there. So then I'm done, right? That's all I need to do. So we get this one, and then we also get this one. The enantiomer of it, well, this isn't an enantiomer because it's not chiral, but you know what I'm saying. And then our byproduct is going to be H3O plus. And that's it. I'm done. So this is what we need to know for the methyl shift, okay? So there's one other rearrangement that we've yet to talk about, and that rearrangement is the ring expansion, all right? So in the next video, we will be talking about the ring expansion. So again, hopefully this was helpful. I appreciate you watching, and I will see you in the next video.